Alright, so this excuse me, this is actually quite a harder example in that there are some sort of a lot of substitution going on, and it's not that it's hard. You need to really be awake, careful. You can't just fall asleep while doing this problem. All right, so let's get started. Um, if we let R1 be the first root, then R2 will be 2 times R1 because it's twice the other, right? Now we'll use this one theorem used in the previous video also. By the way, the three thoughts means therefore. So therefore, x squared minus r1 plus r2 x plus r1 r2 equals 0. Just sort of separate this. Now, this theorem is key. Essentially, without this theorem, you can't solve this problem, So, okay, so R1 plus R2, right? R2 is 2R1, so that gives us 3R, 3R1, right? Because 2R1 plus 1R1 equals 3R1. So then you get x squared minus 3R1x plus R1 R2. What's R1 times R2 must be equal to 0 according to the condition specified. Okay. Now, if we divide this thing by k, because to use this theorem it must be a coefficient of 1, we would get x squared minus 3 over kx plus 10 over k, and that'd be equal to 0, right? Okay, so now we know that r root 1 times root 2, this is the c term, right? But we know root 2 is 2 times r1, so essentially we could rewrite this right here as 2 times r root 1 squared, right? We would write 2 times root 1 squared. Okay, so we can say that 2 times root 1 squared equals 10 over k, right? 10 over k. So, and also we can tell that 3r1, because right here, your b term must be equal to negative 3 over k. Alright, so from that, r1 must be equal to negative 1k. You just simply isolate r1. R1 equals negative 1 over k. Okay, so if we come back here, one root is twice the other. Remember, one root is twice the other, which is back to here. R2 equals 2R1. We can substitute everything in here. R1 is now negative 1 over k, right? R1 is negative 1 over k, and R2, which was trying to find R2. So, essentially, we can rewrite it like this. Use different color, blue. 2 times negative 1 over k squared must equals 10 over k. And this is because root root 1 is the first root, root 2 is the second root, and if we substitute everything in here, r1 and r2 is just 2r squared. So 2r squared must equal 10k right here. 10k, this is your c term. This is your c term, and your c term is equal to r1 times r2. If r2 is 2r1, 2r1 times 2r1 is 2 root 1 squared, 2 root 1 squared. But however, r1 is negative 1 over k, so 2 times negative 1 over k squared is 10 over k. Thus, after you simplify this, you get 0 equals to 5k squared minus k, and then 0 will be equal to k times 5k minus 1. K is 0, or 1/5. Obviously, if k is 0, it can't be 0, or else you wouldn't have an x squared term. So k must be equals to 1/5, and that would be your answer. And if you have extra time in the test, you can go back and check it in, no problem, but that'd be your answer.